Okay.
We cannot hear you, Mr. Sam.
Did you hear me?
Yeah, but not Mr. Sam.
Mr. Sam.
Something wrong with his microphone.
Let me see.
Yeah,
Can you hear me now?
yeah.
Okay, now.
You-
Okay, sorry about that. Look like my microphone on my other unit is not working. Okay, so number one, the channel of a JFET is between the answer is B as in Bob, the drain and source. Right here, you can see the drain and the source. So it's flow right through here. That's the channel. Okay, so for the P channel, it's going to be from right here, right in the center. Okay, so the answer is B as in Bob, from the drain to the source, drain to the source. Okay, number two, the JFET is, okay, it's a unipolar device as well as it is also a voltage controlling device, because you got the voltage at the gate here that controlling how to open up the channel that will be flowing between from the D to S, okay, from the drain to the source. So everything is controlled by the voltage at the gate or gate source right here, GS. So if you put the voltage at the GS, that would open up this drain. So this is represent a unipolar because it's only go from so it's going from here to here only one way from P to P, or for an N it's N channel. So this is representing a unipolar. They call it unipolar, N to N or P to P. Okay. So it's a unipolar as well as a voltage controlling device because you control by VG. So the answer is actually D. All the answers A and B. Okay. So that's number two. The answer is D. Number three, for VGS equals 0 volt, the drain current becomes constant when VDS exceed. Okay, mainly exceed VP. Okay, and that is from this. So it would be from here from the lecture. Okay, so you got from the pinch off all the way to the breakdown. That is your constant IDS right here, constant current area. Okay, so the answer is C as in cat for number three. So any question number 1, 2, or 3? Okay. All right, next one. Okay, all right, so question number 4. A JFET always operates with the gate to source PN junction in reverse bias, okay? So we're gonna be looking at this one here, okay? It's opposite and reverse bias. Okay, so the answer is A as an apple from for number 4. Number 5, the constant current area of a JFET lies between, like I said, the answer is D as in David, between pinch off and breakdown. Okay, so this is constant area right here. So from the pinch off to the breakdown area. Okay, so the answer is D as in David for number 5. Number 6, IDSS is the maximum possible drain current. Okay. So you have is this IDSS anything right here. This is represent your maximum. Okay. Okay, so the answer is C as in cat for number 6. So any question number 4, 5, or 6? Okay, no question. All right, next set. Number 7, the drain current in a constant current area increases when, okay, so mainly the gate to the source bias voltage decreases. Okay, so mainly, so the answer is A as an apple. So you can follow the formula ID because IDSS times the quantity 1 minus VGS divided by VGS off that quantity square. Okay, so if you decrease the voltage, the source, so if you keep on decreasing this one, then you will hit the maximum amount of current, which is the maximum would be 1, which is the maximum would be IDSS. Okay, so you keep on decreasing this one, it's going to get smaller and smaller, and eventually you're going to you hit the maximum. Okay, number 8, in a certain FET circuit, VGS equals 0, VDS of VDD equals 15 volt, IDSS equals 15 milliamps, and RD equals 470 ohms. Okay, if RD decreased to 330 ohm, IDSS is okay. So RD is decreased from 470 to 330. So therefore, the ID stays with the equals still your IDSS, which is 15 milliamps. If there is if there's an increase in the RD, then the ID would decrease it. But in this case, it's decrease in resistance. So therefore, there's no change in current. So whatever the maximum current possible, that's what you're going to have. So the answer is C, as in cat, for number 8. Okay, number 9, at cutoff, the JFET channel is, okay, so it's going to be completely closed, completely closed in depletion. Okay, at cutoff, there's no current ID, therefore the channel is completely closed by depletion region. So you're going to be pretty much right here. It's going to be completely, this is going to be, the channel would be completely closed off, and there's no current flowing from D to S, okay? So that's what that comes into. So the answer is B, as in Bob, for number 9. Okay, any question number 7, 8, or 9? Okay. Next set. Okay, a certain JFET data sheet gives a VGS off equals -4 volt. The pinch off voltage VP. Okay, the VP is the opposite. It's the opposite of VGS off, or the absolute value of VGS off. So in this case, it's a -4 volt. So the opposite of that is going to be +4 volt. Okay, so VP is +4 volt. So the answer is D, as in David, for number 10. Number 11, the JFET in question 10 is an N channel, because you got the VGS is a negative number. So VGS is negative, therefore it's an N channel. Let me see if I have something a little bit clear on that. No, I don't. Okay, so that's represented an N channel. Okay, so number 12, for a certain JFET, IGSS equal 10 nanoamp at VGS equal 10 volt. The input resistance is, okay, so you got the, pretty much you're going to just get the voltage divided by the current. So resistance equal voltage divided by current, or VGS divided by IGSS, which is 10 volt divided by 10 nanoamp. Okay, so that would come to 1 to the 9th ohm, or 1000 times 10 to the 6 ohm. So that's 1000, and 10 to the 6 would be represent mega. Okay, so that would be the answer is C, as in cat, for number 12. Okay, any question number 10, 11, or 12? Okay, let me see in the chat. Someone else says, okay. Okay, so look like everybody. Okay, 10, 11, and 12. Okay, next set, page down. Okay, a certain D MOSFET is biased at VGS equals 0 volt. Its data sheet specify IDSS equals to 20 milliamps and VGS off equals -5 volt. The value of the drain current is, so you got the formula. So ID equal IDSS times the quantity 1 minus VGS or divided by VGS off, that quantity is square. So you substitute in those values. So IDSS is 20 milliamps times 1 minus the 0 volt divided by -5 volt, that quantity square. So that just comes to ID equals IDSS, or 20 milliamps. So the answer is C as in cat for number 13. Okay, number 14, an N-channel D MOSFET with a positive VGS is operating in the, that will be operating in the enhancement mode. Okay, it will be here. Okay, so this is enhancement MOSFET transfer characteristic. Okay, so it's opposite. So this one. Okay, so they look at the D. Okay, so I was looking at the wrong one. Okay, so but it's let me see for the D. So it's opposite. It work in the enhancement mode. Let me see. That will be here. Okay, so D MOSFET. Okay, D MOSFET would be here, and it's opposite. So it is supposed to be opposite in working in the P channel. So P channel is here. Okay, VGS off is positive, so positive here. So P channel for the D MOSFET. Okay, so this is represent your, so it's a P channel or your enhancement. Opposite work in the enhancement mode. Okay. That will be somewhere here. Okay. All right, so the next one, so the answer is B as in Bob for number 14. Number 15, and a certain P channel E MOSFET has a VGS TH equals -2 volt. If VGS equals 0 volt, the drain current is, okay, it's going to be 0 amps. Okay. Okay, so we got the P channel. This is represent your E MOSFET transfer characteristic. This is your P channel. Okay. As you can see, when VGS off, VGS is at 0 volt, there's no current until it hit the trigger point. The trigger threshold would be right here at the negative, and that's when your current start to develop. So anything at VGS off will be 0 current. So therefore, so the answer for that one is A as an apple for number 15. Okay, any question number 13, 14, or 15? Okay, no question. All right, next set. I will just explain about that. Okay. So the common source amplifier. Okay, so therefore the source is going to be connected to the ground. So the input is coming through the gate, and you're going to get to measure the output in the drain. So therefore it's going to be out of phase. It's going to be 180-degree out of phase from the input, and plus you're taking the measurement at the drain. So the answer is A and C. So the answer is D is your answer. D as in David for 16. Okay. 17, for small signal operation and N channel, JFET must be biased at. Okay, so we'll have the bias between negative VGS off and VGS and less than 0 volt. Okay, so as you can see, is this one right here. It's in between those. Okay, so VGS from 0 all the way down to the negative side. Okay, so from 0 to negative, 0 to negative VGS off. Okay, so therefore it's the answer is C as in cat for number 17. Okay, number 18, if there's an internal open between the drain and the source in the CS amplifier, the drain current is equal to, mainly it's going to go equal to VDD. It's there's nothing else to go through. Okay, so it's going to be right here. So if it's completely open, if internal is open, so the voltage here at the drain would equal to the whatever the drain voltage would be. Okay, so it's coming directly here, going to directly here. So the drain voltage. So the answer is for that one would be the answer is B as in Bob for number 18. Okay, any question number 16, 17, or 18? Okay, no question. All right. Okay, so that's pretty much it. Back to you, Mr. Pham. Thank you.
Thank you, Sam.
You're welcome.
Okay, today that's the last one I try to review to you on the JFET amplifier and the MOSFET. Okay, so what I want you to do, quickly do it for me. This one we already done somewhere. That's what I given to you, that answer. That's supposed to be VS, okay? What VD you get?
6.468.
I given you the formula. That is the formula.
5.5.
The 5.53.
Yes.
Okay, that will be then to VGSQ. You know that will be equal to VG minus VF. And VG is 0 minus VF. So they will be equal minus 1.78. That is the formula. Calculate the GM 0. Who get the answer?
I got 8.
Correct. 8 millisiemen.
8 millisiemen. TM.
And GM, I given you the formula. Who get it?
I'm not sure. I got 3.25.
Perfect. You do much better.
Thank you.
Okay, 3.25. G input impedance. Easy.
10 mega ohm.
Exactly. 10 mega ohm. Output impedance.
It's 3.3 kilo ohm.
What you get?
3.3 kilo ohm.
3.3, right?
Uh-huh.
Perfect. The gain. I given you the formula.
Is it 10.7?
10.7.
7.
Perfect. Basically 725.
Yes.
That'd be fine. Yeah, last one.
Is it 6.4 volt?
Ah. VL equal gain
Ah,
AV time VE.
it's 10.56.
Not yet. Who get? I want the vote. I am at. Voted I am at. Just take the gain time the input.
Okay, 34.8.
What is the gain? The gain. The gain is 10.7.
Right, times the input. Oh, I'm sorry. Yeah, the VNI didn't take the right number. I actually don't see the right number anymore. I think it's 10 millivolt, right? Hidden there.
What I get? I think the input will be 100 millivolt. So you take a gain 10.7 times 100 millivolt. Okay, so you get any question regarding into this problem? That will be a common source amplifier. Okay, it is no question. Let's see, next one. This is the answer for the one we already done. Okay, now for this circuit, the question is, what input resistance is seen by the signal source? That means the signal source in here. When they're looking into the amplifier, what the input resistance, that's what we call GE. Okay, so what you have to do, first thing, they say IGSS equal 30 millinanoamp at the VGS 10 volt. So basically we need to know what the input resistance at the gate in here. Okay, so you have to do calculation. That resistance. You're using the formula R in gate equal VGS divide IGSS. Okay, and go ahead and calculate, telling me what you get that first.
$333 mega ohm,
Yeah, 333.
0.3.
No,
Okay.
my answer will be 333. Okay, that means at the source in here, you're looking into the gate. You get the input resistance for the gate 333 mega ohm. Also, you can see another one, RG 10 mega ohm. So basically, input resistance seen by signal source. A RG will be parallel with are in gate. Okay, telling me what value you get.
$9.8 megohm.
Is it 8?
9.8.
Okay, 9.8, perfect. 9.8. Okay, so any question regarding into this problem? Okay. Next one. Now, they're talking about the MOSFET. They given to you idea that 200 milliamp and GM 200 millisievert. They want to know, first thing, DC drain voltage VD. Then they want AC output voltage. If they given to you, V in 500 millivolt IMF. I've given you a little help on the solution. It says since the amplifier is zero bias, okay? Therefore, ID equal IDSS equal 200 milliamp. And if you want to calculate the VD, the VDD minus ID times RD, and the output impedance, G out. You have to know that before you're able to calculate the V out. The gain, then the V out.
Mr. Pham. Mr. Pham,
Yeah,
on solution A, it says since the amplifier is zero bias, does that mean this is because the source is grounded?
the gate and the source grounded.
The gate and the source. Oh yeah.
Mr. Pham, the VD appears to be 8.4 volt.
VD 8.4 volt. That's what your calculation, right?
Yes.
Perfect. 8.4. Output impedance. You understand? And in this situation, they get the load equal to K. So the output impedance will be RD parallel RL.
That appears to be 32.8 ohm.
Perfect. 32.9. Or 0.8, that be fine. Okay, the last one. V out equal GM time G out. That is the gate. Time V in, you get the V out.
Is it 3.29 volt?
Perfect. 3.29. So on the final, if I given you calculation, I given you the formula. The thing is you don't have enough time. You're looking for the formula. Okay, any question?
Mr. Pham, how come we got 3.29 for V out? GM is 200, right?
Let's see. You get the output impedance 32.9 ohm,
Okay,
and you time GM.
GM is 200.
200, and you time 500.
Times V. Oh, yeah. Okay, yeah, you're right.
Yeah, V in 500. Okay, any question? Otherwise, the last one. That also I given you the solution. You do your calculation to see can you get that answer the same as I did it. Anything different, let me know. The reason I bring it up, that kind of problem, the thing in the final, if you do calculation, then I given you the formula.
Professor Pham, for the final, how much time will we have to complete it?
50 question, 8138 minutes.
Okay, thank you.
Normally, when you calculate it, you can say on a one question here take you how long? 1 minute or 2 minutes?
I'm sorry, did you say the final's gonna be 15 questions? That's it?
50.
Oh, 50. Okay, that makes sense. All right, cool.
For one calculation, take your guy how long? 1 minute, 2 minutes, or 3 minutes?
Yeah, we have to move fast for sure.
What?
We have to do the calculations fast, right? If it's 50 questions in 1 hour.
The thing I like to know, so that's why sometimes I given only one calculation for 3 minutes or 2 calculation for 3 minutes. I believe 2 will be okay. If you already have a formula.
Yeah, if there's a formula, 2 for every 3 minutes is doable.
The thing that you cannot memorize or not the formula, even myself. So that's why I given the formula. You keep doing over and over. Some time, at a certain time, you can memorize it. That's what we wanted.
Could you explain how to calculate the output impedance? I see it's RD parallel the resistance load. Can you just go over that real quick though?
Output impedance, right?
Yes.
That means you're looking from the output to the amplifier to see how many resistance. So basically, in the AC, you don't have any more 5 volt. They will be routed here. So you get a RD connect to the drain to the ground, and also at the drain you get the RL connect from the drain to the ground. So that's why RD, RL will be in parallel. That's what we already telling you right here. This is the MOSFET. The formula calculated gain will be the same like the JFET. That means if you want to calculate the gain, there will be GM times G out. Okay, any question? So look like all my calculation is correct.
I'm still not getting the same answer for output impedance. Could you show me like your numbers that you did to calculate that?
D parallel RL.
Okay.
That's what I gave it to you here. RD times RL divide RD plus RL.
So 3.11 would be a correct answer for output impedance, 3.1 kilo ohm.
3.1. I think okay.
Okay. All right. Thank you.
Welcome. Okay, any more question? Okay, so that will be done. Okay, last time, about 3 weeks ago, one of my students, he already completed the program for a while. And now he wants to review, try to doing something in the classroom. She asking me to let him go into the classroom. And I said, at this time, I cannot help. The reason is you not register for the class. Okay, so that's why if you want, register for the class for the summer. A minor difference before 2020. That means before 2020, I get on the power. I can register for anyone to get into the program. However, at this time, I don't know what city tried to do. They said at a certain date, no more register. So that's why I cannot help. So I just like to let you guys know, even you already completed, then still register. Doesn't matter one or two, but you're able to access into the program anytime. Okay. I will be asking CD to solve my problem. The thing is, take one, when they get everything done on take one, then they will be moved to take two. If they're not allowed to register, what can I do? That cannot apply that way to this electronic program. And I hope they return to normal. Then we don't have any problem. Okay? So that is the best I can do for you guys. And now Sam tried to run last week.
I'm sorry, Mr. Pham, a clarification on what you stated. So it means that if we haven't completed everything we can, I know that to register for electronics too, we need a permission code, correct?
That means you said after you complete, right?
Okay, so I guess no permission code until we complete all the work is what you're saying, correct?
Right. If you done all the work we're asking for,
Got it.
we don't care about the time. Nobody tried to let me know they get 900 hours. They graduate now, and not in this program. Maybe you not get enough 900 hours, but you already complete everything we're asking for. You still be get a certificate.
Mhm.
And if you cannot do anything, just try collect the hour. You can stay with me for a couple of years.
Okay.
Okay?
Got it. Okay.
Is it right, Mr. Smith? Okay, Sam.
Okay, Mr. Pham. Okay, make sure you download the answer sheet from the website. This is the e-quiz number 9. Okay, so let me see, quiz number 9. Okay, here we go. Let me see, share screen. Okay, let me see, set up slideshow. Okay, share screen. Okay, slideshow, start from the beginning. Okay, can you all see the quiz?
Yeah.
Yes.
Okay.
What? Can I help you? Okay, so you get any question?
Can I see number 3 and 4 again, please?
Maybe Sam get a problem.
Thank you.
Sam, there was only a total of 14, right? 14 questions?
Yeah,
All right.
Mr. Sam speaker dead today.
My speaker's dead. No, there's no many option on my computer now. It's like, okay.
okay,
Yeah.
So any other question before we call it a night?
No,
Okay,
okay, so thank you, Sam.
you're welcome. Okay,
thank you, Mr. Pham.
Good night.
good night.
Good
Thank
night.
you. Bye.
Thank you.
Bye.
Good night.
Bye. Bye.
Bye-bye.